Let us understand the nodal analysis technique with one more example where current sources are involved. In the previous example, voltage sources are considered. In this, current sources are available. So the current in this particular branch is fixed, that is 3.1 amperes, which is entering like this and this is leaving like this. The current in this branch is minus 1.4 amperes. Okay, so what are the steps? First step is identify the number of principal nodes in the problem. There are three principal nodes are there. One is A, the other one is B, the other one is C. Consider one node as the reference node and assume that the voltage drop at that node is 0. So we have considered C as the reference node and the voltage drop at that is 0. Let us assume that the voltage drop at node A is V1, node B is V2 with respect to this reference node. And even assume that the currents in the branches AC, AB, BC as I1, I2 and I3. So I have considered the direction of current I1 like this. It's not compulsory that you consider always going towards this reference node. It's not compulsory. You remember one point. So at this principal node, consider at least one current as incoming current and one current component as outgoing. Rest all the current components may be incoming, may be outgoing, that is your wish. Here I1 is the current in this, I2 is the current in this and I3 is the current in this particular branch. Now that I1 is equal to one side of this resistor is V1, the other side is 0. So I is equal to V1 minus 0 by 2. And I2 is the current from node A towards node B. So one side of this resistor voltage drop is V1, the other side of this is V2. So V1 minus V2 by 5. I3 is equal to one side of this resistor voltage drop is V2, the other side is 0, right? Now we are going to apply KCL at the first principal node A. So 3.1 is the incoming, I1, I2 are outgoing. So we'll get 3.1 is equal to I1 plus I2. Substitute the value of I1 and I2 in this equation. This equation gets converted into an equation which is only function of the node voltages. Now again we are going to apply KCL at node B. So here I2 is incoming. This 1.4 amperes current is also outgoing. I3 also outgoing. So you can say I2 is equal to I3 plus minus 1.4 amperes. So substitute the value of I2 and I3 in this. We will get the equation as a function of V1 and V2. Solving the equations, first one and the second one, we will get the values of V1 as 5 volts and V2 as 2 volts. We can use these voltages in order to find the other quantities like current flowing through one branch or power consumed by another component, like that. So after the completion of this particular video, I believe that the student had acquired the knowledge of defining branch and what is a node. Student will be able to identify the number of nodes in the given problem, can able to apply KCL and write equations which are the functions of known voltages and design the circuit and calculate the unknown values, can able to analyze the circuit using one among the analysis methods. Thank you very much.